Hello everyone. So today we are going to talk about the sklearn.preprocessing package or the pre-processing module inside the Scikit-Learn library, and in that we are going to talk about missing values specifically. So let's get started. So our agenda or the points that I'm going to cover in this video are prerequisites, introduction, documentation, and then a sample code. So the prerequisites are Python, NumPy, and Pandas. So Python, of course, is the main prerequisite because Scikit-Learn library is inside Python. So you need to know Python to write the code. And NumPy and Pandas, these are really good to know because you will be using these, and with the help of these, you only can you truly utilize the complete features provided by the Scikit-Learn library or the pre-processing module in it. Now, introduction. So, firstly, missing values. What are missing values? Like the name suggests, if the data or if one specific entry in a data is missing, that is missing value. It's as simple as that. So handling missing values is necessary and it is one of the pre-processing tasks, and it makes a huge impact on the model. There are various models that cannot handle missing values by themselves, and if they are not handled by the programmer, then the model is affected greatly. I mean, there is huge impact on accuracy. So pre-processing is really important, and one of the major factor of pre-processing is handling missing values. Now, how are missing values represented? So in a data set, usually when you see a blank value is something that is a missing value. But when we are talking about a data frame in pandas, the missing values are usually represented by NaN. So it is also called as not a number. So that is how missing values are represented. So whenever you see something like NaN written in a data set, if you're coding in Python, that is a missing value to be short. And why are missing values present? So missing values can be present due to various reasons, and some of them are human error. So let's say if someone is entering data, so there are people who do data entry, and sometimes it is possible that one skips a row or one skips one specific entry, and due to human error or maybe while entering, so due to human error, it is possible that missing values are created. Another possible reason can be corrupted data. So corrupted data, again, the data can be corrupted due to various reasons, and I need not mention all of them. But even sometimes during the transmission, maybe sometimes during the change of the file type. So some of these do cause missing values, even if the value was entered, but during transmission, the data gets corrupted or due to other reasons, and then missing values are created. And intentional. So sometimes missing values are intentional, especially let's say if you're filling a form, or let's say if you're filling a survey, and there will be optional fields. So of course, not all of the people will be answering that and will leave it intentionally blank. So that is an example of intentional missing value. Now, moving on, what are the types of missing values? So there's three major types: missing completely at random. So as the name suggests, these in this, like, the missing value is completely random and you cannot predict it using a different variable or a different feature, and let's say a probability of missing value is equal everywhere. So it's completely random and you cannot really make sense out of it as to why it is missing. Then the other one is missing at random, or MAR. So in this, you can use one specific feature and you can understand or make sense out of it as to why the other feature is missing for that specific row. Like for example, let's say if there is a form collecting data, so there will be various fields like, let's say, name, there's going to be age, there's going to be gender, etc. So it can be observed many times, and let's say in this situation, let's say the person who collected the data observed that wherever the gender was female, the age was missing most of the times. So that is some kind of logical deduction, or you use a different feature, that is the gender, to understand why another feature is missing in that row, that is the age. So it's still missing at random, but then it's not completely random, and you can maybe make a little bit sense out of it as to why is this missing, or when will this value be missing. You can understand that. Now the third category is missing not at random, or MNAR. So this basically means that it has been either intentionally left out or something like that. So for example, let's say if there is a survey and uh, they're asking you a lot of details including your salary, so you might not want to disclose some information that is personal to you, and you will not even have any other feature to know that this is missing. Like in the second example, I told you that based on the gender, it was understood that age is missing. But in this case, in this third point, you won't have any different feature which will help you understand that this value will be missing. And so that's what makes it different. And it is missing not at random because it was intentional in a way. And that was an example. So yes. Now, how do you handle missing values? So there are two main, uh, you know, tricks to handle missing values. One is imputing and other one is deleting. Imputing basically means assigning, to be talking exactly in the sense of the word. But over here, what we are doing when we say imputing is that we are replacing the missing value with a different value. Now that different value can be constant, it can be mean, median, or mode. So these are the most common ways of imputing missing values, and that can be done using a Scikit-Learn library. And the other method how you can handle missing values is simply deleting them. Now, when we're talking about deleting, you cannot delete one specific entry in a table. You have to either delete the complete row or the complete column. Because if you delete one specific entry, so to remove the missing value, it means that the other rows will shift upward or shift left side or something like that. And that will completely change the dynamics of the data set. So when we are talking about deleting a missing value, it means you have to completely delete the row or completely delete the column so that the shape of the data set, or let's say the uniformity, is not affected. And how do you decide now when to impute and when to delete? So when missing values are completely random, you can impute them, and when they are, let's say, not at random, you can even delete them. So it also depends upon the data set, and you cannot just say based on the type of missing value. But let's say if your data set has thousands of rows and there's only two missing values, now you probably might not require these two missing values, these two rows, because thousands of rows are more than enough, and these two rows are negligible in front of those, so you can directly delete it over there. So when there's less missing values, then also you can delete. Or let's say there's just one specific column that has a lot of missing values, then you can delete that column. So these are few instances when you can delete, and sometimes you just have to try both the things to see which is providing better accuracy. You just cannot know beforehand, before trying. So you can try both of them and see which one provides better results. Now moving on, we'll see documentation. So this is the official documentation for pre-processing in Scikit-Learn, and there are a lot of topics in this. So today we are just going to discuss about missing values or imputation of missing values, because Scikit-Learn does not really have an imputer for deleting the values. So imputation of missing values is something you can do using the Scikit-Learn.preprocessing package, and I've just clicked on it. You can just search this website and go through it. Now when you're talking about imputing missing values, so there are various things. Now let's see. So there are something like univariate or multivariate imputation. Then there's also sample code, and there's a lot of things over here, including references, nearest neighbor imputation. So you can even use the KNN algorithm, which we have discussed in the Scikit-Learn videos. So the KNN algorithm, you can use it to impute the missing values. So what you can do is you can see which value should be present over there based on the nearest values. So after plotting them on a, let's say n-dimensional space. So using this KNN algorithm, you can also impute the missing values. Then you can also put a constant, and there's a lot of things. So you can go through this documentation in your own time. And let's go back to our presentation. So next up we have sample code, and we'll be using Google Colab for writing the code, and you can also use that. It is a pretty simple online tool. So let us open Google Colab. So this is what Google Colab looks like. If you have seen the previous videos from Scikit-Learn, you already know how Google Colab works, and you can just put in the link collab.research.google.com, and also create your own file, an IPYNB file. So you can write the Python code over here and run it live. So let's start coding. We'll see a sample code, and we are going to import numpy, and we'll import pandas. So these two are must, and it's basically used in any Python code if you go through it. So we'll take a variable named x and we'll create a data frame. So pd dot data frame. Now we can also use the datasets present inbuilt in the Scikit-Learn library, but if you must have seen the previous videos, they do not really have missing values. So it is not really suitable in this scenario, because we want to have missing values so that we can see how we can handle them. And that's why what I'm going to do is I'm going to just convert an array into a data frame, and in that array I'm going to insert missing values randomly somewhere. So now x equals to pd dot data frame, and now we have to take np dot array. So the array is going to be converted to the data frame. So now we just have to put the values. So I can just put something like 5, 2, 3. If I want to put a missing value, I have to put it as NaN, but simply putting NaN will give us an error, so we have to put np.nan. So that helps the NumPy library to understand that this is a missing value or this is not a number. And let's say I'll put another missing value, and I can put 4, I can put -3. So how many are these? 3 and 3, 6, 7. Okay, so 8, 9, 10, 11. Let's take 15 so that we can shape our data as 5 rows and 3 columns, or 3 rows and 5 columns. So these are 3, 4, 5, 6, 7, 8, 9, 10, 11. So we need 4 more. I'll just take some random numbers. Let's say 10. I'll just put another missing value. Okay, I've lost count again. 3 and 3, 6, 3, 9, 12, 14, and we just need one more. So now we also have to reshape it. because even though we are converting it to a data frame, the system must understand that how many columns are there and how many rows. Because if you see, these are 15 entries, but then 15 can be created as 3 cross 5 or 5 cross 3, both as well. So we have to reshape it. So dot reshape, and we can put 5 comma 3. So I hope that works. So it is connecting, and first time Google Colab, it takes a few moments to connect with the server and then run, but after that it goes on pretty smoothly, and we can then proceed with the code. So I'll just wait for it to initialize and run. So now it is connected. So yes, this is working fine. We can just print and see. Print x. So like you can see, we have created rows and columns, and I've basically created an array and converted it to a data frame of 5 cross 3 dimension. So there are 5 rows and 3 columns. Now the columns are named as 0, 1 and 2, so you can also give your own names to the column. So I'll just name the columns equals to, so it will be easy to understand. F1, let's say F1 as in feature 1, F2 for feature 2, and F3. So that should give a name to our columns. It has, and this is just the index, the row number, you can say. And I'm also taking a new variable and storing the same data frame in it, so that if we make changes and if we want our old data frame, it is already stored inside. So let us proceed with the code. Now I have put you can see 4 missing values in this, and let's say if I want to see how many missing values are there, I can simply just put x dot is null and sum. So that will give me the sum of missing values from each feature. So as you can see, F1 has 1 missing values, that is this. F2 has 3 missing values, and F3 has 0 missing values. And now we can also see the total missing values in our data set. So for that you will have to do x dot is null dot sum and again dot sum. So what it showed with a single dot sum, but now we are using dot sum twice. So it basically adds up all the number of missing values and gives it to you. So we have 4 missing values, that is correct. And now what we are going to see is how sklearn how we can use sklearn to handle these missing values. So from sklearn dot impute, import missing indicator, and now we'll take a variable indicator equals to missing indicator and missing values equals to np.nan. Now okay, over here it's capital I. Now again indicator equals to indicator dot fit, okay, dot fit transform x. So it is transforming x, and now we'll convert it to a data frame. So again indicator equals to pd dot data frame, and we take indicator and we'll name the columns. So we can name the columns as let's name them something like A1, A2 and A3, and now I'll just print indicator. So what the missing indicator does is, okay, there is some error with the code. Okay, so the error says that the shape of the past values is 5 comma 2 and the indices imply 5 comma 3. So it is correct because it is only checking the features with missing values in it. So we have only two such features. If you see, F3 has no missing value, so that's why it says shape of past value is 5 comma 2. So now if I remove this, it should work fine. So it is, and this helps us understand that if there is a missing value, so this is a boolean, it's either true or false. So if it is true, it means that there is a missing value. Now you can see our first column has only one missing value and our second column has three missing values, so you can see it over here. So this missing indicator helps us give a boolean, a boolean outcome of the missing value. And you can also add it as an extra feature to your dataset so that it will help your machine learning model somehow. So now we are going to impute, and again for that we need from sklearn dot impute import simple imputer. Now let's take a variable, say imp equals to simple imputer and missing values equals to np.nan, and again strategy equals to, so strategy uh, can have values like mean, median, and not mode, but yes, mode, but then it is written as most frequent for this, and there's also constant. So we'll try with mean first, and I'll just print this. So we are transforming it and then we're printing it. Now if you see that what the imputer has done is it has converted our data frame back to an array, a numpy array. So now we'll have to again convert it back to data frame. So I can just put pd.dataframe over here, pd.data. So now it has been converted back to data frame, and you can also name the columns, and I just put it into X again so that it is stored in the variable, and print X, of course. So it's been stored in X again, and I just name the columns back to F1, F2 and F3. And moving ahead, now we can see that this has been replaced by the mean. So if you go back to the columns, the original data set, we had 5, -3, 8 and 10. So the total of the values over here which are not missing is 20, and the mean becomes 5. So this NaN is replaced by 5. Now again in F2 if you see, this is 2 and this is 2, so the mean is 2, so it will replace all the missing values with 2. In F3 stays as it is. Now let's say if mean, let's say median. So when putting median, Now our second value was missing, right? Yes. So okay, coincidentally our median in this is 5 as well. So it's replaced by 5, and in F2 also the median is 2. So if I change the data a little bit, it will be changed. But then like you see that this time it's replacing my median, and it's enough to understand what mean and median is. I hope you all know the difference. Mean is basically the average, and median is the number in the center after all the values are arranged in ascending order, or even descending order is the same. And that's what median is. And also most frequent or mode, so you can also use that. So again, it's providing the same result over here coincidentally due to the type of data we have. But since our first row there is no repetition in any value, that's why it's taking the first value itself, because no value is repeated. However, in the second feature again there is 2 repeated, so 2 has the highest frequency. So again all the missing values will be represented, will be imputed with 2. Now, I also mentioned that another way of handling missing values is by deleting them. Now, how do you delete them? So, sklearn imputer has limited capability, and it is better to just delete it using the drop na method. So let's say df equals to z. So if you remember, we have taken an extra variable over here z, and we have put x into it. So z dot drop na, and we put access equals to 0. So now we'll do print df. So what this does is access equals to 0 means all the rows will be dropped. So there are a total of 3 rows where we have missing values. So this is 1 row, this is 2, this is 3. So it drops these rows directly, and we have the remainder rows. However, if you see, the index number are showing as they were originally, and it has not been updated, like it has not been changed. So if you want to drop the columns with missing values, you just have to put access equals to 1. So this is a very easy way to drop the missing values. Now only F3 was the column with no missing values, that's why you can see F3 over here. Now, so what I was saying is, so if you want to reset the index over here, so Python has a simple way. So you can just put df dot reset index, and in place equals to true. So this resets the index, and earlier it was showing 0 and 2, now it is showing 0, 1. So it has reset the index, and this is how you can simply drop the missing values. So yes, I think that's it. So that's it from this video, and we'll talk more into depth about the Scikit-Learn pre-processing package in the upcoming videos. Thank you for watching.